Welcome, Calculus AB. This is section 1-2, finding limits graphically and numerically, part 2. The essential question is, what's the relation between epsilon and delta in these notes? Let's begin. So we've seen this notation before. The limit of f of x as x approaches c equals L. And it looks really technical, but it's kind of informal because we don't have exact meanings for some things. Like, what's f of x becomes arbitrarily close to L? Well, how close to L is it? And x approaches c, but how close is approaching to c? And we need to use some mathematically rigorous meanings of this. So one way to do this is through the epsilon delta definition of a limit. So instead of saying f of x becomes arbitrarily close to L, we use an epsilon. Epsilon's a really small number. So f of x is in this range. L is minus epsilon, L plus epsilon. So you got your L, and it's just going between a little bit above and a little bit below. And another way to write this graphically or with an inequality is the absolute value of the difference of f of x minus L is less than epsilon. So that difference between you got your L and your f of x function, that difference is going to be whatever, it's plus or minus, it's still going to, absolute value of that is going to be less than epsilon. Now x approaches c, we can use the delta here. So delta again is a small number. So x of x is in one of two ranges. It's take your c minus d, so somewhere between c and minus a delta, or somewhere between c and plus a delta. Basically everywhere except for c itself. X is not going to be there. And one way to write that with an inequality is the absolute value of x minus c is greater than 0, but also less than delta. So the difference there is going to be somewhere between 0 and delta. Not actually 0 and not actually delta, but somewhere in that range. And how do we apply this to a problem? So I want to find the delta in this problem. I'm given the limit, and limit of 2x minus 3 as x approaches 3 is 1. So you could plug that in and figure it out. So I want to find a delta such that the function f of x minus L, so this is like f of x and this is L, is less than 1/100th, which is going to be your epsilon. And whenever the absolute value of x minus 3, and 3 is your c, is between 0 and delta. So what you want to do is you want to take this function for epsilon, and we're going to try to rearrange it to look like a c function. So you're going to rearrange this one to look like this function. So I'm going to rewrite this in combined like terms. That's going to be the absolute value of 2x minus 6 is less than 1/100th. Oops, I wrote that wrong. Not 1/10. Oh, too much erasing. There we go. Now, I can factor out 2 from there. So I'm going to rewrite this as 2 times the absolute value of x minus 3 is less than 1/100th. And notice that's kind of similar to this guy right here. So if I divided both sides by 2, that becomes the absolute value of x minus 3 is less than 0.01 divided by 2, which is the same thing as 0.005, 5 thousandths. So the absolute value of x minus 3 is less than 5 thousandths. So that means my delta d, and it's plugging in like this, is going to be equal to 5 thousandths. And I'm going to write it just like that. All right, that's it. Just one example, and we'll do more in class. See you later.